Western civilization is moving closer to a point of irreconcilable, unstable equilibrium, as frighteningly increasing numbers of people trust nothing. Media, academia, and especially the governments are no longer held in high esteem. Regaining trust is often impossible after betrayal. However, transparency is essential to any healing process, and that is the essence of the Don Sullivan Show. Please listen to the team explore, probe, and debate cutting-edge science, technology, and computing. Play ball! Hello. This is Don Sullivan again for the second episode of the Don Sullivan Show. My buddy Jersey Steve is here. I have a guest, Oleg Ulyanov, and we're going to have both of them introduce themselves. I'm going to give you a little introduction to start with. But I want to reiterate the purpose of the Don Sullivan Show, and that is to discuss every aspect of science, technology, and computing from a level that the general American public, that is the teenage mind, can fully understand and fully grasp. Today, we're going to have an interesting subject, and that we're going to talk about the power of networking processing, the power of the network. But first, let's again reiterate and talk a little bit more about who I am and what we're doing. I'm a 30 to 40-year veteran of Silicon Valley. But the truth is, I'm not really a geek. I just play one at work. I'm really a coach. I'm a sports guy. And so we are going to address all of these subjects from the perspective of not only entertainment, not only intense activity from a coaching and almost athletic perspective. We're going to address it from the perspective that this is material that everyone in the United States and the Western civilization needs and should understand, again, from the perspective of science, technology, and computing. So, Jersey Steve, you want to talk to us a little bit about yourself, and then I want to introduce our guest for today, Mr. Oleg Ulyanov.
It would be my pleasure. So I'm a 20-year veteran of the IT space. Also not a geek, although probably not a jock either. In high school, I wore hemp necklaces and listened to the Grateful Dead. So I don't know where that puts me, Don, but...
you should see some of the concerts we go to, folks.
Oh, yeah. They're Red Rocks.
All right. So I want to introduce you now to my friend and colleague. We've been working together for a very long time, Oleg Ulyanov. Oleg is a Russian native, born in Moscow, and is presently a German citizen and has been in Germany for quite a long time and has been working with all of us at VMware for about a decade plus. And he is an expert in a lot of different areas. He is an absolutely brilliant human being. He is a networking expert. He is a database expert. And he is a mountain climber that dwarfs me. He has actually climbed the highest peak in Tajikistan that approaches 25,000 feet. So this is a very impressive individual, and we are honored to have Oleg on the Don Sullivan Show with us. Anything else that you want to add there for quickness purposes, Oleg?
Thank you, Don. Thank you for that introduction, even if it's a little bit probably, how would call it, more than I would like to be talked about at the beginning, but I'm really pleased to be at this show, and thank you guys for inviting me. And as Don mentioned, right, I've been wearing a number of hats, right, and one of them a networking expert. So I would be happy to talk about networking, right, because that's basically the key for almost everything that we have right now in our digital world, right? So with that, let us get started.
And since Oleg knows pretty much every language in the world, every language in Europe, I mean, he could actually be Pope in that regard. We want to make sure we're going to keep this with English. The only language that Steve and I know is New Jersey. So we're going to try to keep it to the to real English, and so that the entire audience can understand all the way through this entire version of the Don Sullivan Show. All right. So again, today, Oleg, we really do want to talk about the present state of networking. So over a very long period of time, we've always looked at four dimensions of performance. We've looked at the storage access, the networking access, the processing, and memory. And of all of those things, typically we have always thought that access to the storage is the most difficult to perform, is the highest bottleneck in regards to overall performance. But that's not totally true. It's really about network access. It's about the different types of networks access. Broadly speaking, network connections, Ethernet using IP, HBAs, host bus adapters going to actual storage, direct storage, or any other component of connectivity to the storage has acted as a bottleneck. Oleg, this isn't really true anymore, is it? Things have advanced in the last few years, especially since COVID. Tell us about that.
Yeah, and that's the interesting part, right? And I would let us start from the beginning, right? I mean, it's a number of things that changed a lot through like 30, 40 years that we have the digital things around us, right? And to start with, we would have a very slow connection from your endpoint going to a server, right? So it's really like if you will go back to 1980s, 1990s, you will have a modem device that you will need to connect to, and then you will have like what your 50, 56 kilobit, right? That's the best that you can get. And that is where you don't need actually your server to perform that well to be able to respond to a client. Now the thing changing, right? And if you will look at the amount of data the clients are looking, and internet user are looking to get in a matter of seconds, right? Not to start with to talk about all the AI stuff. We'll come to that at a later point, right? Just to look at the amount of data that needs to be transferred. That is where you will see without networking, actually all of our server, all of our devices would make no sense, right? They will just stay there and probably hit the roof, right? That's a nice thing to do, but you actually cannot use that. So that's why networking is always a key. And it's always fascinated me through the last 15 years. How the folks working with databases, working on the storage side of the house, they would always say, oh, like on my side, everything is cool. Let us blame networking if something wouldn't perform well, right? But that's the key, right? Without networking, your data is meaningless, right? You cannot use it. So for now, in the last 5 years, I think what is happening, it's a really revolution in networking. And if you will look at it at the speed, right, we saw when a 10 gig Ethernet being introduced, that will be probably enough for everything, right? Back to the days, right, Don? And now we have 800 gigabit, right, on the same Ethernet technologies, which is fascinating, right? No one thought about it. No one thought that it's even possible. However, that is where we live, right? And still, what especially fascinates me on all of that, they're still able to use Ethernet technology, which were designed for 10 megabit speed, right? Right? It's the same stuff that we used to have like 40 years ago. And even if all the new shiny things like InfiniBand, right, or all other things coming into play, they definitely have a place to be, right? But still, probably 95% of all the data is still being transferred over normal Ethernet networking. And with the current speed and current access, that's just a matter of fact if you'll see like doubling what we have right now in terms of this. And in order to be able to serve all of that, right, we'll need a different approach to cables, to technologies, to things, right? So just to summarize it a bit, basically networking right now is a key out of all of the technology. If you will take networking out, everything will just make no sense, right? Because you're not able to use it.
Yeah, it's interesting that you talked about Ethernet and how we've been using it forever, but it sounds like there's a hard limit. You know, we're only going to get so much out of it. So you see new approaches being necessary for the future.
That's exactly true. That's exactly true.
And obviously your dog agrees totally with what you're saying there, Oleg. And I'm glad for that. I'm glad we have ubiquitous agreement throughout the entire world, all the way into Europe and the dogs. You know, I want to narrow this a little bit more directly, though. Talk to me about the processing capability that exists on our onboard network information cards. That's something that fascinates me. So for a long time, that was just a pass-through in terms of the actual data. Now, the actual processing can intelligently take place. This is almost a pre-AI type of concept, right? But the intelligence exists so that the right processing can take place on the network information card and actually amplify an order of magnitude more the actual effectiveness of the network information cards that allow for that network bandwidth to actually be amplified rather than just the volume be larger. But tell me a little bit about where we're at with that, because again, this is a post-COVID development, really, in terms of the magnitude, right?
Absolutely. And thank you, Don, for bringing this up, right? It's literally, so what is happening in terms of the networking, right? As we talked about, there's enormous amount of data that needs to be transferred, and enormous amount of things happening on the network adapter. That is where you will see need to have a separate processor for processing this data outside of the major TPU. And the reason for that, if you look at what current CPUs that we have on the server could be used for, it's a number of different things, right? Number of different processors. And in order to keep up with the current speed, right, as I mentioned, 800 gigabit is there. If we would be using CPU just for that, we probably would actually, CPU would use all the power just to do networking traffic. And it's not only transferring the data, right? We also would like to add some additional services, right? We would like to have additional capabilities. We would like to filter the traffic. We would like to do any DPU stuff. We would like to do a lot of things on the traffic, on the fly, on the current speed. So that is where we are going, right? So that is where we would see a chip located, a chip based on the networking card. And with that chip, we would be able to work not only streaming the data, we would also add all the additional services. And we also would spare CPU capacity for everything else that normal CPU would have to done here. So that is the major thing. And as I mentioned, right? So basically networking card is starting to be like a computer itself. And with that, you can offload a number of things, right? And with that offloading capabilities,
you can offload things onto the cards.
Exactly.
So all the networking, all the chip makers are focused as much on developing the chips that go on the networking cards as they are on the server chips, right?
Exactly. And that is the thing, right? Just because you're not able to keep up with the current speed, right? You're just not able to pass this data through CPU, through memory, and then get it into your path for the networking. It just, you wouldn't be able to do it on the line rate, right? Especially if you will look, okay, if we are talking about server cards, that is the one thing, but if you will look what is happening on the switching layer, right? So when you have a switch capable of 48 800 gigabit ports, right? That's a different story. You're not able to use just a single processor inside of the switch, right? You will need to have an onboard chip for each and every port inside of that switch.
So Oleg, does this, and Steve, you can jump in here, and I might be being a little naive with this because this is obviously the clouds came along 20 years ago, at least in theory. But is this really what makes a public cloud possible in terms of real viability to actually use for true processing and accomplishment as opposed to just a place to store stuff?
It's a very interesting question. And okay, so the thing is, right, when we look at a way how public cloud networking operates, right? So like, we wouldn't be mentioning any names just to be sure we're not violating anything, right? Just let us stay with public cloud as it is, right? However, the thing is, if you will look at the design of networking of public cloud components, it's something you have never seen at your data center. You would never seen like a server having just a single Ethernet adapter. And you will never see like overcommitted switches. So basically what is happening inside of the public cloud, from one end, it's a dramatical need for high performance, for high throughput of the networking. And from the other side of the house, it's a price, right? So as soon as you will have all the redundancy, all the enterprise networking, someone will need to pay for it. And who is going to pay for it? It's actually users. As soon as you will put this bill on the user side, no one is going to use it. So the things that public cloud vendors done, they basically reduce the price by saying, sometimes you can probably leave having your services down for sometimes. Sometimes you can leave as having, some issues here and there. However, what they do, they provide that on a scale, right? And on a scale means it's really massive, right? So instead of having just a handful of devices connected, with 20 connections just to provide all the redundancy, all the has-been, how we will do with normal enterprise database setup, they will just use a single connection on top, right? And just say, now we have everything's there. And with this enormous speed that we have, they still able to keep up with the throughput and with the requirement of the users. Yeah, so it's really interesting thing, right? And I believe what is happening with the public cloud right now is basically, how would call it? It's to some extent, it's a matter of having this high-speed networking and ability to provide this networking, and from other hand, is ability to deliver it at a low cost. And the combination of that is what we have, and that is what we call the public cloud. And another thing to mention, it's also, and I talk a little bit about modem connections, right, that we used to have 1980s, 1990s sometimes, right? What increased a lot is a last mile connection for end users. So right now, if we look at a fiber networking, like 1 gig networking, connecting each and every house, each and every flat, that's very different from what we have 30 years ago, right? And it was just impossible if you have like 56 kilobits per second to do anything on the public cloud, right? And so a lot of things right now has been transferred to the endpoints. And endpoints have this connectivity to be able to consume resources out of the public cloud. And now we are coming to the place, right? So between users and public cloud, we have something in between, right? And this something in between is basically called your internet network. And that is where we've seen a huge improvement over last decade, right? So the backbones of the internet networking is definitely, that is what made public cloud to the place where they are right now. Without the internet backbone, what we would have is just isolated islands of public cloud, and then users not able to basically consume the services because last mile is not enough for that, or connection between them is not enough, right? So, and also just imagine what will happen if you have your server located in America and then users being in Europe, right? So are you going to really have this traffic to cross Atlantic and wait for the latencies that we have here? No, it's not, right?
Well, there's the question that I really want to ask. Yeah, it's the point, and it's the perfect segue to the question of whether or not the bandwidth, which of course was created with the internet in the 1950s by the U.S. military and added a little bit by major U.S. and European companies, has the bandwidth kept up to be able to handle what the immense amount of data that's been accumulated and being processed and passed by the servers, the chips and the servers, and now the chips and the networking cards. Has the bandwidth really kept up? Is there a unanimity between them, or is it out of balance at this point?
It's actually two dimensions there, right? It's not only bandwidth, it's also latency, right? The thing is, as you can imagine, right, you can have a very nice bandwidth. However, if your latency is 20 milliseconds, 40 milliseconds, 100 milliseconds, it's just unusable. Right? It's just unusable. So that is the thing. And the speed of light is nice, right? However, what we need to ensure that the packet that is going out, I don't know, out of a small village near Frankfurt, then go to New Jersey, right? And then going back and I can receive the response, right? So that is
Einstein did not do us a solid in that way.
You see? So that is the point. And what actually we have seen a lot of progress is is what is happening with the latency, right? This low latency connection that is right now being a center of all the internet backbones, right? That is the key for what we have right now. Because as soon as for all the video streaming, for all the everything that we have, right, it would make no sense if you would need to retransmit or if you're like missing like 50% of the frames, right? It just make it unusable. And for sure, we need a bandwidth to be able to pass it. However, bandwidth, I would say, is a secondary in terms of latency, right? As soon as you are not able, like, if you will look, I don't know, basketball, right? And you're streaming something, and then it will be delays like every 10 seconds. You will probably drop the stream like in 1 minute or 3 minutes, right? Just because what you will see, right? You will see, oh, that is the score, or that's probably the ball has been moved somewhere, right? And now it's nothing happening, right?
Yeah, it really bugs me when I hear the actual audio being, a tenth of a second ahead of the video when I'm watching various
Exactly.
sporting events. I can't stand that. So, and that is not acceptable. A zeroth world problem.
We're
I
very
can't take it.
impatient.
You see, so that is the thing where we'll see why latency is sometimes much more important than bandwidth, right?
From your perspective, when announcer yells goal, they still got the ball up at the top of the it's going across half field. Is that the right words? And the announcer's yelling goal. They're like, no, I wanted to see the whole play.
Exactly.
Given the fact that we all want real-time content and real-time, and businesses want real-time access, they want immediate insights. How is that? What kind of challenges are there? Challenges right now in networking to accomplish that, or do they basically have that figured out?
That's not right. As always, it's more or less, if you will look, it's approximation of your through output, bandwidth, and resulting latency, right? And the thing is, as more streaming channel you have, more bandwidth you will need to have, and less bandwidth will be then more latency. So in terms of what is happening, I would say we see data transfer being double close to every half a year, right? And also, like right now, users would not look at any pictures which will be less than HD, right? You will also just skip it, right? As soon as you will see something like basketball play or soccer play, right? And it's not an HD quality, I wouldn't bother me looking at it, right? So what does it mean in terms of networking? We need to transmit everything. We need to make sure that it's also in near real time at least, and we have this low latency connection. So and the thing is, it's not only the internet backbone that we need to get there. We also need to have this end mile. And a lot has been done, especially in Europe, to improve this end mile, right? Because your connection from home to the internet, that is where also a lot of latency and bandwidth loss happening, right? And then if you have a small village and then you have only one small cable going from this small
Yeah,
village.
the bottleneck can happen anywhere.
Exactly.
Along the
Exactly.
entire
But
course.
that is the thing, right? And that's why networking is so fascinating, right? It's, for example, a lot of focus being made to improve these big channels, right, that are used to transfer it from data centers to data center, right? And at some point they figured out, oh, like, and my user is still using like modem connections. They actually cannot consume the services that we are ready to provide. So that's why it was a huge things done like 2010 to improve this last mile. And improving this last mile, they figured out, oh, now my backbone connection are not able to keep up, right? Just because my user are now having all this like 1 gig, for example, ready to stream, and we are not able to provide it on this matter.
So it sounds like a balancing act.
Exactly.
Yeah, and the different components get ahead of the other, and you've got to get them, all the components, all the steps along the entire network path to be speaking at the same rate in the same language. And,
Yeah.
let me get a little bit more into the weeds here. I'm really interested, I think the audience will be, is if the processors are that are on the network cards are both multi-core, meaning having multi-processors on the same physical chip, or we have multiple actual processing chips. I mean, does it really reach that level of speed of processing on the network cards and on the switches?
It depends, right? And so the thing is, right now, a single core is definitely capable to keep up just with the traffic, right? And
You don't
also,
even need it.
and also the thing
More.
is, right? If you will have multiple cores, and then you will have multiple packets that you are transmitting through that codes, it will cause a number of issues, right? Just because you will need to make sure it's all in order, you will need to make sure that it's actually keep up with the speed, right? So that's why most of what is happening, we will have a single core to work with a network data stream. However, if you would like to have any additional services on top of it, that is where you will see in new modules. That is what is called DPU, right? That is coming into the play, and that is where you can see multiple.
So the services are distributed potentially between the multiple physical chips and the multiple cores on those chips.
Exactly.
That's
so
interesting.
that is where you will see it exactly.
And those are the new advancements and so on. Let me even get a little bit closer, because obviously from a semiconductor industry perspective, I don't know if most of the audience totally realizes that a single smartphone probably has about 20 different chips in them, and they're produced by the various different companies that we all know so well that we won't go through the litany of. But are they are they constructing manufacturing chips that are specific for the networking and the offloading to the networking for the network chips, as opposed to the server chips? Are they that much different? Is effectively creating a sub-industry just within the semiconductor industry for those networking chips?
I mean, for sure that's a difference, right? Even if like the technology itself, and if you will look at a different way how chips are produced right now, and a lot of new things that are invented in this area just to make sure that we can put more chips into a smaller space and all of that things, right? That's the one stuff. The another stuff is when you will look at CPU unit, it's basically designed to handle any stuff. Whatever you throw in, right? It could be storage traffic, it could be network traffic, it could be, now I need to calculate a random point, now I need, to solve some math stuff, right? Everything that I throw in will be taken by a CPU module, and it will work and get it done as fast as they can, right? However, the most important thing, right, is CPU unit are able to work on almost any kind of tasks, right? Once we'll come to a point like GPU unit, network cards, they're very specialized. And that is why we're actually able to get to this point where we have 800 gig in the NAND, right? Just because this chip is only capable of a single thing, like transferring the traffic, analyzing the traffic, like working with the traffic, right? So that is the only thing that this chip is aware of. So what we are doing, we're minimizing amount of instruction on the chip.
So really being customized, whether or not it's a GPU, an IPU, a DPU, just to keep all the companies involved in the discussion, right?
Yeah. Exactly. So the thing is, on a networking chip, as a way how it is right now, you are not able to do close to nothing just to pass the traffic, right? And that is the key here. And if you want to build additional services, you will like to add additional chips, right? And that is the way to go. Just because what we have seen,
and we have the capacity for that, and that's where the massive advancements have occurred over the last number of years, and that's where I really wanted to get to in this discussion. This is really cool stuff.
Exactly, and that is why we see in like semiconductors manufacturers, right? They are on top of the world right now, right? Just because they're able to produce those chips that are being used for different industries.
So you very adeptly answered this question already before I even answered it. It's interesting how you can read my mind there. It's probably a KGB kind of trick, I think, but it's an old KGB kind of trick.
Should be.
But obviously, we're referring to both LANs, local area networks, and WANs, wide area networks, when you were talking about the issues that are occurring from the last mile to the village home south of Frankfurt someplace. And so you obviously address the fact that that need is being addressed and met, if not completed already, in regards to everywhere. We in the United States certainly have a lot of remote access problems, but that's being addressed too in the exact same way. So you're a little closer, certainly in Germany and overall in Europe, but in the U.S. we have the Southwest where we sometimes don't have a gas station more than 75 miles apart, but then that becomes a land between them to a certain extent. It's not really, but between them if there was. But that's being addressed as well, specifically with different types of chips and services on those individual chips. And that's where this becomes absolutely amazing, because it really is totally connecting the world, isn't it?
That's the thing, right? And also, like, one interesting remark, I think, in terms, like, everyone would think about Germany being off top of all technologies. However, in terms of network access and last mile, I think Germany would be like 10 years to get to the point where US is right now, right?
Really?
So even if, like, yeah, I mean, like, as mentioned, I based in a small village, like, but it's still 40 kilometers from Frankfurt.
Just in terms of the actual implementation as opposed to
yeah. However, it's still our long living friend ADSL connection. So the telephone line, I mean, it's really what we have right now. It's nothing else, right? And they're building fiber channel network, and they're telling me it will be like what?
But the technology exists.
Yeah, technology exists, right? However, to bring it to the user, that is taking a lot of time. Really a lot of time.
The infrastructure.
So along those...
Exactly.
Yeah, infrastructure. Along those lines, what I'd like to actually end this up with is discussing the various different types of network access that the general public, this listening audience of the Don Sullivan Show, has an understanding of. And that is, it's obviously been incredible to me for a long time of how in this industry we overuse terminology. There's like only a certain number of terms that we have to use, so we have to keep reusing them. And the same thing with letters. So when we refer to 10G, we're talking about a bandwidth. When we refer to 5G, we're talking about a technology that is, I should say 10G is a bandwidth, but a generation of bandwidth. And 5G is a technology that has superseded the most recent cellular technologies. They are certainly complementary to each other when they have to actually overlap that Venn diagram again. But I'm looking at that also from a perspective to something that has been recently floated by everybody's favorite superhero, Elon Musk, when he is referring to the Starlink direct connect from cell phones. Now, of course, he wants to take over every technology, including cell technology, and the notion that eventually a phone possibly is produced by SpaceX. We won't even talk about that yet, but existing phones having possibility of direct connect to a Starlink satellite, that solves your last mile access, doesn't it?
To your point, right? And it's also just interesting to see how the things just reappears out of nowhere, right? We used to have just a satellite phone, right? A satellite phone existing for like 30 years at least, right? They're able to make a connection to a satellite. You can make a phone calls out of remote area where no mobile network coverage, right? However, what is happening in those areas, right now, such satellite phone would have an ability to connect to the mobile network if it exists, and then switch to a satellite phone if it's needed, right? The only thing that is changing with the new technologies is instead of using these satellites, which are very costly, it's not a lot of them.
Well, that's what Musk is trying to solve.
Exactly. That is exactly. But it's not new, right? I mean, if you will have the same technologies, you will be in the remote areas, such things already exist. The
It's
only
only new
downside.
from a perspective of general access to a
Exactly,
general public.
exactly,
Yeah.
exactly. It's a new from two perspectives, not only from general access, it's also new in terms of bandwidth and latency, right?
Yes.
So what we used to have through the satellite phone connection is like 56 kilobit at the best, right? And what we can do from SpaceX, it's just more or less like a mobile network, right? It's close to no difference, right? So that's
So Starlink is basically satellite phone that's faster and better for the masses.
exactly.
Right. And the existence of all the technologies that we have talked about on this episode of the Don Sullivan Show will enhance that next step. And Musk has obviously taken advantage of that. He has a Steve Jobs like genius in understanding productization and really believes that in the next year or two, we're going to be able to get to a point in which your average cell phone is going to have a service that will allow it to potentially direct connect to a Starlink satellite, even if it's not a specialized phone. And that's all going to be accomplished, I imagine, Oleg, you can comment on this, with all of the different modern, I mean, when I say modern, I mean the last 24 months technologies, the multiple core chips that are on board, the networking chips that are capable of having many actual processors, and the general speed that has been enhanced, as we've talked about. Does that all make sense?
That all definitely makes sense. The one point that I would like to bring is it's interesting to see how networking is actually defining all these new data things, right? So what is happening? You will talk about services, you will talk about Netflix, you will talk about Starlink, whatever technologies you have, right? However, everything that interconnects it all together is a networking. And that's why, to some extent, networking is the key for everything that we see right now, right? And investment in networking is really what allows us to use all of these services, right? So meaning Starlink on itself, without any other services being provided, without being able to access them, it's also useless, right? So that is why an ability to interconnect on a speed, on a scale, that is where we see the power of networking and controlling and providing this networking access. I think that will be one of the key things that a lot of provider will be working hard to be on top of that.
Well, it looks like an amazing, brave new world that is upon us and accelerating tremendously in terms of both services and entertainment. The ability to watch various different real-time events, whether it be political, whether it be disasters that are occurring, such as we're seeing in Southern California right now, or political events in New York, or sporting events in an absolutely real-time basis, outside of what were normal channels just a few years ago, is absolutely breathtaking. So, Steve, I don't know if you've got anything to add.
I was thinking, for the average person, when they think of networks, they probably think of their internet, and internet isn't cheap. I think we pay over $100 a month for high-speed internet. I was curious, what is the pricing model of Starlink? It seems like kind of a connectivity internet democratization play, but somebody's got to pay for these things too. I know Musk has offered it for free, in certain instances, but I'm curious, especially with energy costs, they've risen recently.
Well, Steve, I think that's probably a great segue into some episode in the future. And maybe we'll get somebody from Starlink themselves to come on and talk about it. I know something about it because I've researched it, but I don't know if we should be talking about it right here yet. It is pretty amazing stuff overall. But I think we probably should leave it there. It's a great segue. Oleg, my hope is that we're going to have you on many times in the Don Sullivan Show to talk about the advancements of networking, to talk about a plethora of other things that you are expert at, not just databases, but you've got a certain number of hobbies that fit into the science, technology, and computing realm. And you just have an unbelievable amount of experience. We're going to talk about mountains. We're going to talk about geology. We're going to talk about mountain climbing. You and I have done a bunch of stuff together. We're going to do more. I'm going to climb Kilimanjaro, I hope, in a year and a half. And I've been up and down the Grand Canyon, and you've done 25,000 meter peaks. We're going to talk about all kinds of different things, and it's going to be a lot of fun. over the periods of the next number of years, I hope. So, Oleg, thank you so much for being on this episode and enlightening the Don Sullivan Show audience in regard to the present state in early 2024 of everything having to do with overall networking. And Steve, you want to add anything, or should we wrap up this episode?
Let's wrap it up. Thanks again, Oleg.
Yeah, thank you for having me.
Thank you, sir.